Okay, good afternoon, everybody. Thank you for your time today. My name is John Vignoki, and I'm the Senior Director of Alliances at C3 IoT. Today, just get a quick show of hands. Who's familiar with C3 IoT? Okay. What about AWS IoT? Okay, good. So as a background, C3 IoT is an application development platform for developing next-generation big data, AI, and IoT applications. And AWS IoT is a service that AWS provides to help make it easier to connect devices to the cloud. And so during today's presentation, we're going to be hearing from Philippe Calvez, Adi Basham, Meryl Wittevin, and Riley Siebel, talking about how Engie, one of our mutual C3 IoT and AWS customers, is using the C3 IoT platform and AWS IoT to accelerate their application roadmap. And then we're going to turn it over to Adi, Meryl, and Riley to give you a demonstration of the application development platform. And so with that, Felipe.
Hi, thank you. Hi, I'm Philippe Calvez. I'm stream leader for the IoT at Engie. Who knows Engie in this company? Okay. So we'll go first with a small overview of Engie. Engie is a world first leader for producing energy in the world. It's independent, and it has more than 150,000 employees. And the most important is it's present in 70 countries. We are organized with 40 BUs and more than 1,500 companies around the world. This means that it's quite a complex company, a quite complex organization. And we have decided to do some transformations, a 3D transformation for decarbonize, digitalize, and decarbonate. This means that by 2030, half of the production of Engie will move from fossil energy to sun farms and wind farms. And for this transformation, for the digitalization, we have we decided to develop mainstream at Engie for mobile application, data analytics, and IoT. And more than €1 billion will be invested in this digital transformation. Engie is involved in all the energy chain, from production to delivering gas and energy to the end users, and must have also solutions for territories, for cities, and for business. We are present on all the gas transformation chain, from centralized production of electricity. To answer this big challenge, as we have to deliver application for our BUs, Engie has set up a digital factory, Engie Digital. It's a new company set up last year with three main topics. A customer hub. The idea is to centralize all the demand from our BUs and from the business. The studio, the goal of the studio is to spread all over the company the good practice and the agility, onboarding the BU and the project inside our company, and to help them to be alone when they have to run their own application. And the factory, it's a technology platform where we develop the application, we develop content for the BUs, and the idea is to develop this content for the business units. So we want to have applications that can be run for the same business unit all over the world with reuse of the technology which have been developed for these BUs. So the streams are in this factory are mobile apps, IoT, integration of data analytics, and API. All this technology we have done the choice that they will be cloud-based, and the choice of the cloud is Amazon. As Engie is a very old company, digital is not its main core business. So we were not able to do all this thing by ourselves. So we decided to do strong partnership with different companies. For authentication, or user authentication, we choose Okta, which is based on AWS. For the mobile application development tool, we choose Kony. For data analytics and data integration, we choose C3 IoT. You will have a demo of the new product just behind. And for data acquisition and IoT data acquisition and device management, we develop our own solution on AWS IoT. All this data will be reachable through APIs, open APIs, and we choose Axway as our partner for promoting these APIs. And the last strong partnership we have is with Thales. It's the only company which is not AWS based. It's for the general security, global security and operations center. In the next slide, we'll see what we've done on the AWS IoT platform. Okay, this platform was first dedicated to get data from IoT devices and to do the device management for all these devices. In fact, there is very few cases of IoT. In Engie, we have a lot of plants where the devices already exist and are behind SCADA. So we have to deal with these issues. And so we enhance our platform to a data acquisition platform where we can collect data from different systems, which can be SCADA, BMS, SFTP, POST, or any other devices, IP devices directly. The first goal of this platform was to manage the devices, collect the data from these devices, transform the data from binary to JSON payload, and then monitor the platform, monitor the devices, and then send all these devices, the content received from these devices, either to C3 IoT when we have analytics issues, or to legacy systems where application already exists in Engie, and we don't need analytics in the first time at least. Because our platform is able also to route all data received to any system, both C3 IoT and legacy system if needed. If we go deeper in the architecture, the way it's done, this application is fully serverless. It's 100% based on Lambda systems, and so we have two kind of backend. One backend for dealing with the front end. The front end is written in Angular 4 and is communicating with the backend through API gateway and Lambda. We also use DynamoDB to deal with all the users and the permission given to the users. Lambda functions are also used in the backend to collect all the data. Everything, for example, when data are posted to our API gateway, the transformation of data is done through Lambda functions. We also use AWS IoT registry for registering all the devices from IoT. By IoT, we mean LPW1. So this means that we only deal with devices that are communicating with LoRa or LoRa operated networks or Sigfox networks. In France, we have two LoRa operators, Orange and Obgenius. If we go deeper in how we get the data from IoT devices, the IoT device is connected through to the API gateway and is authenticated by a Lambda authorizer. If you attend the previous meeting, you know how it works. Then the acquisition is done, and at this level, we do transformation between binary and JSON payload, and we post all the data in the MQTT broker, update the shadow, and publish the data in the MQTT. Then a rule is put on every topics, and on each topic, and when there is a new data on the topics, this data is pushed either to C3 IoT or legacy systems through Lambda functions. Now we will focus on different use cases where we use C3 IoT for delivering application to our customers. On the left-hand side, it's we use C3 IoT residential module to deliver information to end user, so to user which are customer, customer of our client. Sorry. This is done for one French operator, which is Engie particulier, which sell gas for the B2C market, and for Electrabel in Belgium, where it's Electrabel send electricity to end users. C3 for B2B market, we have a major program in Italy called Clara Domus, where we do some optimization, building optimization, and in that case, we have two kinds of data coming from the field, data coming from Sigfox network or data coming from BMS systems. The reason why we have developed this kind of interface, and all the data then are fed to C3 IoT. And we also use C3 IoT for other purposes. It's a program called Digital Operation. Engie has many plants in the world, and some plants, for example, in Oman, we have two plants which are absolutely identical, but we have 5% difference in efficiency on these plants. So the goal was to collect data from these two plants, select the right data to collect, and then send them to C3 IoT, where our teams with C3 IoT people develop algorithm to understand why we had such discrepancy between the two plants. Okay, so this is what we achieve with smart building on the Clara Domus project in Italy. We have this program was launched 1 year ago. Now it's running live. We have more than 500 buildings connected to the platform, with more than 16,000 sensors connected. The target within the two or three next years is to have more than 3,500 buildings and more than 100,000 sensors connected to the platform. The goal is to give tools to the building manager in order to optimize energy consumption of their buildings, and also to be able to compare what buildings are, to benchmark buildings by their energy consumption by square meters. This is a second, on this curve, you can see that 2 or 3 buildings are consuming much more than expected. The funny thing is that this building was sold as efficiency, specifically efficient buildings to people. Okay, sorry. The other thing was to provide those. The other application we had was for B2C market. So we have co-developed with our BU, which is selling gas in France. And we have exactly the same kind of application for BU that sells electricity in Belgium. So we have two programs. One is called Mastermind. The other one is called EMR. But the idea is exactly the same, is try to give our customers information about their consumption and advice on how to decrease their consumption, to consume less and to pay less. And in that case, all the data are fed are retrieved from different systems in Belgium or in France, go through our IoT integration platform, transform, and then push in C3 IoT for analysis and benchmarking. Okay. In that case, what we noticed that we have very encouraging KPI. And the goal is to have more people going on their website, because initially Engie was selling only gas to people, and our goal is to have more customers, not for gas, but for electricity, because we are allowed to sell electricity. We have a very small market share, in electricity, and staying longer on the website for this company will encourage people to see other offers and maybe to have an electricity contract. Okay, now I will move to C3 IoT and explain what is the concept of the Center of Excellence we have set up in France for speeding the development of all these applications. Thank you.
All right, thank you. So with the Engie Digital program, C3 and Engie have established what we call a Center of Excellence. And the Center of Excellence is supposed to help Engie accelerate and be successful with this digital transformation initiative. So you can tell they have a very broad vision. They have about 30 applications that they want to be developing. But in order to do that, for a customer that's not inherently a software company or a technology company, they need some sort of structure and governance and support to ensure that they're successful in scoping the right projects and identifying the data sources and in training on the various C3 IoT and AWS services. And so we established this Center of Excellence. It's located in Paris and also in North America in our headquarters of Redwood City. And we're training up to 100 Engie data scientists, developers, operations personnel, and also injecting our own resources to ensure that they're successful. And this spans their entire business, so all five of their operating units, or 5 of their lines of business and 24 operating units. So quickly on the platform and what C3 IoT has done. So what we've built here, that's a little bit, it's much different than kind of the general kind of what we call a flea market in the sky, what you can go to an open source Hadoop landscape or from other kind of cloud service providers, is basically in order to develop these types of applications, there's a bunch of various services that you can go out and start, inspecting and playing with. But in order to actually develop an application that applies machine learning at scale on disparate data sets that are IoT data, non-IoT data, you need to do a lot of stitching together. And, oops, there we go. Depending on how you stitch this together, it could go very well or it could not be that great. And a lot of times in our customers' experience is that you end up spending more time integrating these services and ensuring that they're working together. And a lot of times they're not designed to work together. And so as you continue adding models, algorithms, applications, you have to continue stitching together more and more services or change the way that these services are integrated. What C3 has done differently is we've taken a different approach, using a model-driven architecture to pre-integrate these disparate technology components into a single unified object model, what we call the C3 type system. And when you're developing on the C3 type system, it provides a cohesive and consistent medium to access all of the platform services. So this is everything from data integration, cluster management, model development, model management, application development, all the way through that entire spectrum to your entire user base. So you have your data scientists, your app developers accessing this type system, writing their Java, their JavaScript, their Python, and their R code. And so that's kind of what differentiates the way that we've developed this platform. Now, taking a look at the actual architecture, this is our very detailed architecture. You can find this on our website. But on the far left-hand side, you can get a sense as to the different types of data that we can accept. It's pretty much anything. Any data, structured, unstructured, semi-structured. We have our data integration process. I didn't touch that, it was impressive. Data integrator, we have our platform engine, pre-integrated with over 40 AWS services and hundreds of AWS APIs, our machine learning layer, and then our visualization layer where you can design and develop and deploy your own applications, which is what we'll demonstrate to you shortly. And so in order to make this whole process of developing AI and IoT applications much simpler and to provide users with kind of cohesive learning experience where you can just sign up on the website and get going, we've launched this new product called C3 Orion. And what C3 Orion allows you to do is to quickly build and operate AI and IoT applications. And it also integrates cohesive learning experience that Marilyn Riley will demonstrate right now.
Thanks, John.
Thank you, John. All right, so John gave a little bit of an overview of what Orion tries to do, but what we want to accomplish with Orion is that we take away our impact at C3, or we take away our role as C3 in helping customers to develop these AI and IoT applications and to operate these applications. So what we want to do is we want to have data scientists and developers sign up online and actually build applications, operate these applications without us interfering in. So with that, let's look at a little bit of a demo here.
Yeah, so let's show you this application that I want to build. Today, I want to build an application which I call Lightbulb PM, Lightbulb Predictive Maintenance. And the idea here is pretty simple. I have smart light bulbs. They're sending data in real time to the platform. And we want to look at historical data, build a little machine learning model, and predict failure in these smart bulbs over the next 3 months, and build a UI so that our building managers could, for example, purchase the right number of light bulbs for the next month, but not too many.
So let's have a look at that actual application. So as we're opening here the UI of this actual application, the application is pretty simple. It consists of 3 UI components, a graph on the top, a map in the middle, and another grid on the bottom. And on the left-hand side, you see a filter panel. And what this application is doing is it lets these building operators know when their light bulbs are prone to failure. So it lets them order these light bulbs in time and avoid dangerous situations where these light bulbs go off. Now, this application is pretty simple. It has this histogram on top with, it has the risk score. So there are 21 light bulbs with a risk score between 20 and 30%. Then if we scroll down a little bit, we see where our light bulbs are located. And we've indicated in green the light bulbs that have a very low risk score of failing, and in red the light bulbs that are very prone to failure. And at the bottom, we have a grid that shows each of these light bulbs and their failure risk score. Now let's take a look at how we actually built this application.
So C3 Orion is an integrated platform for building, operating, and learning about how to build and operate IoT and AI applications. So we built that application in about an hour using this tool, and we're just going to jump in and show you how we did it.
So when you want to build an application, what we did for this light bulb application is we created a data model by creating C3 types. We integrated and loaded data. We analyzed time series. We built a machine learning model. And we developed a UI. And all these tools that I just mentioned are here shown on the left. So let's jump in.
The first thing we did was we built a data model, right? So in here, we're going to show you the types which are relevant for the data of this application. In this case, the basic one is the smart bulb itself. Here I have a smart bulb with lots of fields. Those fields are themselves of various types. For example, I have a field called bulb events, which is an array of smart bulb event. Some of these fields are stored in Cassandra. Some of these fields are stored in Postgres. Some of this data is in S3. As an application developer, I kind of don't care. And by the way, if someone switches Postgres for Oracle DB or whatever, everything keeps working. So in addition to smart bulb type, I'll just briefly show you some things. I could add a new field. Maybe this field is of type decimal, and I want it to be a calculated field, so it's calculated based on an expression, based on other things in the database. All right, or I could do all kinds of other things, make it an enumerated field, whatever. That would work across any sort of database, whether that database has built-in calculated field support or not. I could also add methods. And when I add these methods, I could decide to implement them in JavaScript or Python in this case. And any function written in any language can be called from any other language as if it were implemented in that language through the C3 type system. Some other types I have include a smart bulb event type. This represents an event that happens to a smart bulb. For example, lightning strikes are interesting events for smart bulbs that break. Also, turning a light bulb on and off is an interesting event for identifying failures. Smart bulb measurements are measuring continuous time series data. This is going to be power, essentially. Then, at the end, what I want to do is I want to have predictions about what's going to happen to my light bulb. What's the probability that it's going to fail? So this smart bulb prediction type, let's drag it over there. This shows you kind of the object relationship between these things, which is kind of cool. But the smart bulb prediction is going to hold the result of the machine learning algorithm. And then just to show you that a lot of things are types you might not think are types, in this case, our transforms themselves are actually types. So this is a transform telling you how to get from the data directly from the smart bulb into the data model. And there's some simple expressions you can see in here that are telling you how to do that kind of stuff.
So now that we've created our data model, which consists of a smart bulb event, smart bulb measurement, and a smart bulb prediction, it's time to load some data. And we've preloaded some data for this demo. And what you can see is there are 3 files that we uploaded here. There is a canonical smart bulb file, there's a measurement file, and the smart bulb status file. And what C3 Orion does is it automatically processes these files in batches. So we can see that the first file, there was 1 batch created. The second file, there were over 300. And the last file were 78. And all of this is done automatically. And it's very easy using a visual tool.
And then we can show you, by the way, we just used files because we built this thing in an hour. And then here we have the Data Explorer, where you can come and see data that got loaded. So for example, all the data from that one file got run through that transform type I showed you. And here's just all the data for that type, things like latitude, longitude, including automatic foreign key resolution. So this is a field that comes from some other database table, maybe some other database. Some of these are calculated fields. Some of these came directly from the data load. I sort of don't care, right, again, as an application developer. So once you load the data, the next thing you want to start to do is you want to do time series analysis. Okay? So you have lots of data organized in time. You want to do analysis of this data so that you can identify failures and predict them in the future. So here I'm going to show you some of the analyses that we did on the smart bulb type. So some stuff, right? What's the average voltage? What's the average temperature? What's the average power? How many connectivity events were there? How many times did the switch turn on and off? Did it go out? What's the current risk score? That's actually the output of the machine learning model. And I'll just briefly chart one of these guys so we can show you that it works. So let's look at smart bulb. What's this guy, the SMB LB1, and let's say from 1/1/2012 to 1/1/2013, and let's chart it. All right. Oh, did I do something wrong? 2013. Chart. Right. So here, for example, is all the data calculating this calculation. You notice there's not really JavaScript or Python or code really here. There's just this expression language. So by building these expressions and naming them, in this case average power, I can come in and see what's going on with the average of the normalized power data. Why are there 2 averages? Because you got to average over space and over time. Happy to talk more about that later, but this automatically aggregates or disaggregates. So I could just come in here and say, by the way, calculate that expression instead of at a day interval, at a month interval, and there it is, right? You build these time series analyses into more complex time series analyses. So for example, standard deviation in wattage of the previous week is itself an expression, which is the standard deviation of the average power over the last 7 days, basically. Okay? And I could also chart that, but we don't have too much time. Finally, there's an interesting one that I want to show you, which is going to be important later. This is how we identify, this is how we label our data set. We label our data set using actually time series transformation. Is the thing defective, right? Because eventually we want to predict future defectivity events? Sure. So in this case, what I basically say is for any hour, if the average lumens, meaning the light is 0, and the status is 1, meaning it's turned on, the thing's turned on, it's not producing light, it's defective, right? So this is a metric, this is analysis that can be used to identify failures. Okay, I think, yep, so now we have a data model. We loaded data into the data model. We enhanced our data model with all these transformations of time series, which are themselves accessible essentially as fields on all these types. The next thing we want to do is we want to do our machine learning and our AI. So in this case, I'm going to show you this tool, Ex Machina. Oops. Reload it real quick.
And Ex Machina is our drag and drop machine learning tool that you see right here.
So here what I'm doing is I'm going to build a pipeline, taking data from the system, training a model, using the predictions from that model back into the system, and then using those predictions to build a UI or do whatever it is, send people emails, whatever it is I want to do. Okay, so there's all kinds of stuff you can do in here. We can fetch data from C3. Maybe you have your own HDFS instance. You have a REST API you want to call. You want to connect to HANA, whatever it is. All kinds of analytics you can do. Build your own expressions, which involve logical operators, Scala code, whatever. All sorts of data preparation. You want to filter. You want to split your data. You want to flatten it. You want to convert the unit. You want to merge some things. Too much stuff to talk about. And there's a whole bunch of built-in machine learning algorithms right here. Just some examples I'll point out randomly include PCA transformation, linear regression, k-means predictors, random forest regressions. There's a stack of these things, and you can add more if you'd like. There's a whole bunch of output models, including back into C3, into SAP, send people an email, whatever it is you want to do. I'm just going to talk about this machine learning model briefly. In this case, what I do is I say, let's look at smart bulbs. On smart bulbs, I'm interested, whoops, that was not a good idea. Don't click that button. On these smart bulbs, I'm interested in using these analyses. Has it ever failed? Will it fail next month? By the way, will it fail next month is defined as is defective in the future is true. Okay, I just didn't show that one earlier. How many times has it been switched on and off in the previous week, and how long has it been on? We basically identified that these signals are predictive of failure. Okay, so now we evaluate those signals over the last 6 years at a day interval. Now we start building our machine learning pipeline on top of that. Let's take all this time series data, let's split them. This is your standard, I need a training set, I need a validation set. In this case, we decide to split 70% of the data into the training set and reserve 30 for validation. You do some flattening of the time series and some not so interesting stuff. And then I train a logistic regression model. In this case, I'm going to use the duration it's been on and the switch count as the training features to predict will it fail in the next month, which is my label. And then I run my model. I think, unfortunately, since I changed the thing, it's going to rerun the whole graph, which is going to take about 5 minutes. So meanwhile, we'll go look at the UI.
So now that I've created my data model, I've loaded my data, I did my time series analysis, and I now am able to forecast whether a certain bulb will fail in the near future, it's time to create a UI. And creating a UI with C3 is actually really simple. So we've got this tool UI Designer, and what it does is it lets you add components on the fly. So if you just click that little icon, the eye icon that Riley just showed here, is all the components become editable. So in this case, for instance, we have right now 10 buckets in our top histogram. And let's say I just want to have 5. So let's go into this, this component, and let's just change the number of bins we have to 5. And straight away, it updates this, and it updates the data as we go along here to 5. Now, adding a new component is just as straightforward. So if we scroll down to the bottom, there's still space for another component. Let's say I want to add another grid because I also want to have the latitude and longitude of each of these smart bulbs with their failure, so I can know where they are in a different kind of way. So all I did is I dragged in my grid component and I connect the data source, in this case the bulb, and I just select which of the components of this light bulb I want to see in my grid. So for instance, the latitude, the longitude, the ID, and maybe the prediction. And then we let the backend think a little bit, and there's your grid right away. Easy as that.
So finally, this looks like a BI tool, but we're kind of not done, right? So the next thing you need to do, now that you've built an application, you want to collaborate with a team, push the code that you've built back into the main branch, essentially, and manage your whole CI, testing, and deploy process, right? So one thing we didn't mention was that everything I was doing here was against my own instance of this application. And when I created this instance, it also automatically created a branch in the GitHub repository for me. And everything that we've been doing has been writing back to that GitHub branch code that maybe some of your wizards would like to edit by hand. JSON-like things, JavaScript-like things, Python-like things. In particular, we can jump right in to see what's been going on in this repository. And you can see that, for example, someone changed some stuff in some file, doing whatever it was that they did, and maybe I want to make a pull request now from my branch back into master because I really like this application, I really like the pipeline that I built, or whatever it was. So I can create a pull request right here. Also, I have a build master dashboard where as people are pushing code, I can see what's going on with the tests, build by build. As you can see, we had some weird builds where everything failed, and then things have been looking pretty good since then in terms of builds. This is a very small repository. It's just got the one package, so there's not too much interesting happening here. Once I've done those things, I now maybe want to deploy this, right? So I've got in here every time anyone committed to master, a build was automatically created, all the tests were run. This is a deployable artifact with a version. So I can come right in here and deploy this thing to stage if I wanted to push a build to stage for sharing it with everybody, and then maybe to QA, and then maybe to production.
So this is one part, but once this version is actually deployed, I want to manage this application. I want to manage my environments. I want to see how many instances I use. And I want to see if I maybe want to turn on or off autoscaling. Or here we're looking at a tool that manages your queues. Another tool that we have is environment performance. So here we see we have 2 master nodes working and 1 worker node. And here I can change those numbers, or I can turn off or on the auto scaling. And you can also schedule your cron jobs here in this tool as well. Mm-hmm. Now, if at any point in time I get stuck developing, which happens as developers, we've got integrated learning courses and documentation. Let's look at the documentation first. So we've created all the documentation that we have available. We made that available through this tool. So for instance, a MapReduce tutorial. How do I do a MapReduce? Or how do I install the Eclipse plugin that I can actually write using Eclipse and then push that back to GitHub if I prefer not to use the visual tools. We also have a Stack Overflow-like community where you can leverage the C3 developer community, ask or answer any questions that we have. For instance, here, there are many questions going on every single day. And last but not least, we have a learning portal that has about 8 hours of online learning content and courses given by our C3 developers. So we've created a whole infrastructure around building and operating these AI and IoT applications.
And just to prove something here, this is not, oh, that's the video, we don't want that. This is not just a visual tool. So one thing I mentioned is that everything that you do is written as code back to GitHub. So fine, let's check it out. Get out of the MapReduce tutorial. Let's go back to my environment. And in here, I would like to launch the JavaScript console. So here I am interacting with this application now through a JavaScript-based interface. This can actually help you understand how lines of code written in the type system are converted, for example, to REST API calls. So maybe I want to just look at all the smart bulbs. So here you can see that a REST API call went to my DNS entry, API1, lightbulb, smartbulb, action equals fetch, with some argument and a response. And here I have the response from the, oh, I can't zoom that guy. The response from the database comes back really quick. I can also evaluate any of those time series analyses I did in this console. And this is a way for people to sort of interact with the running system live through this tool.
So we plan to launch C3 Orion in the spring of 2018. But at this time, we are taking beta applications. And we encourage people to actually sign up for a free beta.
Yeah, so what we are offering is that starting in January, we're going to be doing a 3-month closed beta where we want something like 6 teams to join. Okay? A team looks like 5 developers with a lot of data, an interesting AI use case that will make a difference. Okay? And so we really encourage all of you guys to come on to, oh, and you'll get free infrastructure. Everything will be free. All the databases, Kinesis, SQS, AWS IoT, things that you would like to your heart's desire. And basically, we want you to come in, sign up for the beta, apply, and we'll get back to you guys sometime around January with whether you made it. So that's what we got.
Thank you. Yes.
We're really happy to have shown this to you and really appreciate your time. And we have about 20 minutes left. So if anyone has any questions, we're happy to talk about C3, or I'm sure maybe Philippe would take questions. I don't know. But I for sure will be up here for as long as you guys are interested in speaking with us. Thank you so much. So if anyone has any questions, there will be a microphone running around, and we'd love to answer them. Raise your hand. No questions?
Oh, there's one over here.
Okay.
I was just curious how you think about security when you have so many devices that are now connected to the internet, and you're controlling a lot of these IoT devices. So how, maybe if you could talk a little bit about how you handle security.
In fact, there are very simple devices in LP1 protocol. For example, Sigfox, you only have 13 bytes per payload. So we receive the payload as a text, and we apply a match pattern on this text and to derive the content. And if we don't match the content, we reject the content. So we cannot be polluted by these devices. We don't have IP devices directly connected to our platform. Okay. And in fact, the Lambda authorizer at the very beginning check if this device is allowed to discuss with our platform also, before analyzing the content of the payload.
I would also add that AWS IoT has some pretty good built-in security through the MQTT protocol. Mm-hmm. Well, if there's nothing else, thank you so much for your time. We're going to be doing a fuller demonstration of Orion and C3 IoT tomorrow at 3:30, maybe. We have 2 more talks, so search for them and come check us out. And look for us on the expo booth. We've got 4 booths and espresso and affogatos during the happy hour, so I know I'm going to be there for sure. All right, thanks, guys.